Okay, let's take a look at a chi-square goodness of fit example. This is the example from the Jamboard that has been posted on our course homepage. We're looking at the distribution of M&Ms and the color of those M&Ms. And so we can see, according to the manufacturer, we have this distribution here, which is the percent of M&Ms of these colors. And so the null hypothesis for a goodness of fit test is always that it's based on the assumption that the proportions that we actually get, like from this bag here, right, a bag of M&Ms, and here are some data, right, that we've obtained, the observed values, or the counts we have here, that will match up with the proportions stated by the manufacturer. And so those values are the percentages or the proportions of those colors. The alternative hypothesis is that at least one of these proportions is not correct with respect to the sample data, right? These counts or these observed values that we actually got out of the bag. So what we want to test here is whether the M&Ms follow the distribution stated by the M&Ms and Mars company, right? At the alpha level of 5%. Or 0.05 level of significance. So that's our alpha there, 0.05. So there's your null and alternative. We're going to run a chi-squared goodness of fit test. Now to do the calculations, we go to the artistat, and we're going to try to calculate, or we're going to calculate a chi-squared value and a p-value. So let's go ahead, you go to the artistat, and then you're going to go to the chi-squared test option that we have. There we go, right from the web app. So you have chi-square test, and we're now going to do a goodness of fit test, and we're going to use a contingency table since we have the values. Now there are 6 categories because you have the colors there, right? And so for this example, you can put in the colors. So you will see we have brown, yellow, red, blue, orange, and green. So we're going to go ahead and do that. Brown, yellow, red. So we'll put that in. So when we get here, I've entered the data in for us. Contingency table, 6 categories. I want to double check we've entered everything correctly. The proportions, the counts, 57, 64, 54, 70, 86. Make sure that those are entered in correctly. Oops, let me double check. There is 86 and 64. Looks like we got it. Yep. And then the percentages, 13, 14, 13. Let's see. 13, 14, oh yeah, see I have a type already. Percentage of red was 13, so this should be 13, 24, 20, and 16. So that's what we have. And once you have that, you just go ahead and submit, and then you can see we get a chi-square test statistic. Make sure you double check everything. Get your expected values, there we go. In case that's asked for us, we have the observed and what we would expect if it follows, if the color distribution follows what is expected, this is what would be expected. So you can kind of check to see, it looks like someone may be off. But again, we don't officially use that. What we do is we use the test statistic and your p-value. So I get a test statistic of 6.74 and a p-value of 0.24. So you get 6.74 and 0.24 is your p-value. And then we go ahead and make your decision. Alpha is 0.05, and so we're done, right? Since the p-value is greater than alpha, we do not reject H0, right? Do not reject H0. So we see, once we do not reject, there is not sufficient evidence to conclude at least one of the proportions is not correct. So again, what we ended up deciding was that the null hypothesis did not reject this. So we're saying that's good and that this is not right. So we would have evidence to conclude this. So we're kind of in agreement that they are in proportion. The colors do match up.